Okay, welcome to this week's Retrieval Markets Demo Day. Today's date is Wednesday, the 24th of November. Today's schedule, we have Andrew Stewart from Magmo introducing the team and what they're working on. And then we have Wei Liang from Ken Labs talking about Pando metadata service, the new work that they're looking at. If you have any questions, please put them in the Slack channel. I'll start a thread immediately after I pass off the microphone. And yeah, over to you, Andrew.
All right, thank you. I'm going to share my screen. Everybody can see a presentation. Is that right?
Yes. Okay.
Yeah, so let's dig in. As I mentioned, I finished these slides at 11:58, so please bear with me. But today I'm mainly going to talk about Magmo and the work that we've done in the past, but I will also talk about some important things about the project that we're working on here, which is implementing scalable multi-hop payments for the Filecoin retrieval market. So I'll start with a brief introduction to the team. So Magmo is myself, Andrew, George, Mike, Alex, Colin, Tom, and Connie. You can find out more information about us at magmo.com. And in short, I would say that we're a team of, we try to be humble research and development engineers. We're also good friends, and we're willing to take risks, germinating stretch goal research ideas. We're always looking for novel ways for peers to securely interact among themselves, leveraging a public blockchain as a trust layer. So as a bit of history, we formed as a company 3.5 years ago or so, mainly with support from Ethereum Foundation. I recall getting support from somebody else, but I've got a pretty bad memory right now. And then we joined Consensus a couple of years ago under the umbrella of applied R&D officially the company is called Consensus Mesh. And more recently, we've gotten support from the Filecoin Foundation to ship our main project, which is called Nitro protocol, to the Filecoin retrieval market. And I'll also put a little bit of free marketing here, which is that for the past couple of years, we've been working on the State Channels project, which you can find more information about that at www.statechannels.org. And so I'll tell you a bit about what Magmo does. So we focus on open source public goods research projects. We tend to focus on layer 2 technologies, trying to identify user pain points and alleviate them without sacrificing security. And more importantly, I think something that's really special about us is that we invite conversation and collaboration with anybody, as long as it's in line with our mission and our values. And a little bit more about what we don't do. We try not to hold any egos about credit, care about who came up with what idea. In our opinion, our ideas are your ideas. Also, we don't aim to commercialize our output. So your success is our success. To reiterate here, our goal is to improve the security and usability of technology used in decentralized projects. So all of our code should be open sourced. We might have forgotten to license something. If you find something, please raise an issue on GitHub and we'll get at it. And I'll also, put a point out that if anybody does want to take our ideas to market, as this Filecoin project demonstrates, we're going to support you in any way that we can. And, as I mentioned, we don't really polish our marketing. So, if somebody wants to do some free visual stuff for us, that'd be great too. Now, I know that this is a retrieval market demo day, but as you'll find out, I feel that I should talk a little bit more about myself and some things that have happened to me. To start with, I'm from a small town in Outport, Newfoundland. It's on the east coast of Canada. It's a big island, but everybody thinks it's small. And somehow at an early age, I got really interested in mathematics. I picked up a book called Cosmos by Carl Sagan. And in one of the appendices, he proved that square root of 2 was irrational. And I remember just, it blew my mind that you could do things like that. But I didn't know that you could be a mathematician until I met a guy who's also named Andrew. His name is Andrew Critch. And we met at a math camp back in Newfoundland. I also didn't know that there were math camps, so I have to thank my teachers for kind of pushing me in that direction. And eventually I earned a PhD in probability theory, which is key here because a recent series of events has shaken my entire foundational beliefs about statistics, and I can't really help myself from telling the next story, which is how I became a probabilist and what is going on right now. So as I said, Andrew Critch taught me I could be a mathematician. Who is he? He's also a mathematician. He's also from Outport, Newfoundland. And after, learning that I needed to become a mathematician, he later influenced my life in another important way by convincing me with an irrefutable probabilistic argument that I should move to Toronto instead of Vancouver. He told me that my expected utility, my life utility, if I went to U of T, given that I stayed in mathematics, was greater than my expected utility if going to UBC, given that I stayed in math. Likewise, if I left math, my expected utility at U of T was greater than my expected utility at UBC. So if you apply some basic probability theory, you find out that my expected utility is maximized by going to Toronto. Okay. That's how Andrew Critch thinks, and he taught me to think that way, and now I can't stop it. What else does Andrew Critch do? Well, I have to admit we fell out of contact for a couple of years, but it shocked me when yesterday one of Magmo's teammates, Colin Kennedy, pointed out to me that he just gave a talk at the Funding the Commons Summit, hosted by no other than Protocol Labs. So he was talking about this S-process funding. What is S-process funding? It's an algorithm that allows multiple funders to collaboratively find an efficient allocation of public goods funding. And he demonstrates the application of marginal utility functions to form consensus around the most impactful ways to allocate funding. And somehow, consensus apparently forms around Nitro. So hats off to the Ethereum Foundation, Consensus Mesh, and the Filecoin Grants team for your prescience here. With that slight detour completed, I'll get back to the regularly scheduled programming, which is that Magmo is implementing virtual Nitro channels for the Filecoin Retrieval Market. What that means is that various network participants, such as Alice, Bob, Charlie, and David here, can connect to some hub through some on-chain interaction. And afterwards, after they've made these connections, they can quickly and securely form off-chain connections, allowing them to transact directly between each other using Nitro protocol. So a couple of years ago, Magmo, with the help of other contributors to the State Channels project, built a proof of concept application using Nitro protocol called Web3 Torrent. So Web3 Torrent is a shim on top of WebTorrent, which is a WebRTC implementation of BitTorrent. And what we did with Web3 Torrent is we modified the incentivization algorithm used by the BitTorrent protocol. In BitTorrent, a seeder uploads pieces of a file to a leecher. They choke uploads if the leecher detects that if the seeder detects that they asked the leecher for some pieces of data and the leecher refused to provide them. This incentivizes leechers to also be seeders. And as I remember, I think seeders are also altruistically upload pieces. which I think is a key part in making BitTorrent function well. But if anybody knows better than me, then please let us know. So Web3 torrent kind of mutates this incentivization algorithm by enabling leechers to make micropayments to the seeders in exchanges for pieces of a file. So seeders would continue to upload pieces as long as the stream of incoming payments keeps up with the stream of outgoing data. And I can imagine that you can see the parallels here to the Filecoin retrieval market. So what is the problem that we're trying to solve for the Filecoin retrieval market? Well, the Filecoin retrieval market requires efficient micropayments to exchange data and FIL tokens between retrieval miners and clients. Now, Filecoin already supports payment channels, so why do they need Nitro? Well, the reason is that the existing Filecoin payment channels require, well, they essentially require on-chain interaction to set up a relationship between each client and each provider. I would point out that Filecoin channels do support the Lightning-style multi-hop payments using a hash time lock contract construction. But the problem with these constructions is that the liquidity provider, the hub, the person that makes this connection, they have to be involved in every single micropayment. So that definitely doesn't scale, especially when each micropayment involves cryptography, which hogs your CPU. So that's one problem. The other problem that exists in the Filecoin retrieval market today is that there actually is a lot of complexity in the off-chain protocols to support multi-hop payments. And currently, as far as I'm aware, there's no software that takes advantage of the support for HTLCs in Filecoin to support multi-hop payments. So I'll talk a little bit now about the project that we're working on now. The first thing that we're doing is we're translating these off-chain protocols, which are currently written in TypeScript, into Golang so that they can be used by the Filecoin ecosystem. And around these off-chain protocols, we're also building these various system components, a messaging service, a store, and a blockchain service. And the main concern to most of you folks is probably the Go Nitro client. So that's the client that manages channels for you. It opens the channels, it closes the channels. That's what projects like MyL can use to consume and destroy virtual Nitro channels. So this architectural diagram outlines the various components that we need to build. But most of the complexity is actually piled deep into the engine under ideally a relatively narrow interface. So I'll comment a little bit on that decision there. We want the protocols to sit inside the engine as pure functions. Now, I am a mathematician, but I don't know what a monad is. So don't be worried about this fancy terminology. All we want to do here is implement protocols that don't mutate global state or depend on services. The idea here is that this increases portability and testability of their implementations. You can imagine, for instance, if we can compile these protocols to WASM, then we can use them in the browser. We don't have to rewrite them. We don't have to worry about interoperability issues. I guess I was talking too quickly because I thought I would have to skim over this slide. But let me say a little bit about where we've gotten so far in our Go Nitro package. The long story short is we're not a Golang team. We didn't write any Golang before starting this project. So the first thing that we did is we prototyped some of the work included in our grant proposal as a language learning opportunity. I'll share with you I'll send out a bunch of links in some forthcoming communication, including our repository, our project map, and so on and so forth. We do have a substantial amount of the components I would say we have a substantial amount of the interfaces defined already, and some rudimentary prototype implementations of things like the store or the messaging. I think somebody on my team might correct me there. Maybe I'm over promising. But we do have so far one implementation of one of the off-chain protocols. And what we're currently doing is we're getting code and design review from two experienced group of Golang developers. Each group is a domain expert in their respective half of the state channels and the Filecoin equation. So we're hoping to maybe adjust our design based on any of that feedback. And to wrap things up a little bit here, I'll give you a sneak preview into our next demo day, during which one of my teammates will give a more detailed overview of where the project is, where we plan to take it, and maybe even a short demo. I don't want to make public promises, but you know, it could happen. And that, right, there's one more thing. Well, we found out yesterday that Nitro was already taken by some other high impact project. So we've had to suffer a little bit of a rebranding here. With that, it's my pleasure to announce Nitro's new name, which is the Stateful Asset Transfer Protocol. Boring, but you know, whatever. So this paper that you see in the slide here is the end result of a several-month-long collaboration with Polycrypt, who are the maintainers of Perun, which is another state channel protocol, which happens to be implemented in Golang. Together with these folks, we're continuously discovering protocol improvements, which massively reduce the latency and overhead required to construct these virtual channels, especially across more than one hub. In addition, we're increasing the security of these protocols and reducing the cost to do the on-chain operations necessary to recover your funds. As you can see on the date here, we finished, I don't know why it says November 24th. We finished this paper at 11 p.m. last night to make a deadline. And we hope to review the paper next week, make some final edits, and we'll ultimately release our joint paper with Polycrypt with some more details. And with that, I will thank everybody for the time.
Great, thank you, Andrew. And yeah, an incredible coincidence between two probability theorists. And yeah, thank you very much for running through that. As I said before, any questions, please add them to the Slack channel thread. And yeah, let's go on to Ken Labs and Whaley.
Hey guys. Okay, I'm William from Ken Labs. So today I'm going to give you a demo of the metadata service, Pando. So yeah, not just for their bot. So the metadata service. So that's the agenda for today. So I'm going to briefly introduce what Pando is and what it is for, and the high-level architecture. Then I'll move on to a live demo. I remember I didn't give an introduction in previous demo. So the idea is that we want to ensure the access to the notarized metadata, including the testing of miners by their bots, reputation services, availability, and the demand for data. So it's also very important to keep associated and available for the ongoing health of the network. Also, the historic state of these data streams are also useful for the future comparative analysis, and they help us to understand the dynamics of the network. So this is based on this, we have the Pando metadata service. It will provide the service to persist and back up such metadata and provide lightweight query interface to different consumers for various purposes. So this is the background of Pando. And this is the architecture, the high-level architecture. For now, we haven't integrated with any real metadata provider or consumer. So from this architecture, you can see in the middle. So this is the metadata service. We provide interface to provider and the consumers. In general, the provider will publish their IPLD data update to Pando with all the requests received, and Pando will pull all the data from providers over GraphSync. There, you can see in the metadata service mod box. So there's a rate limiter. This is to limit the traffic between providers and the Pando to ensure the service quality. Also, there's a snapshot mechanism in Pando. This is to give a history state management for the whole service. The IPLD data is stored in SDAG in the data storage. It will also provide the two interface to the consumers, the GraphQL API and the GraphSync. So we support both HTTP and the P2P interface. So this is the high-level architecture. So now let me move on to the demo. We have 3 scenarios. First of all, we need to register a provider. For example, a Dearbot. It can use this Pando command line tool to register itself. And then it can send the update to Pando. So in this demo, I'm not going to use Dearbot. Instead, we build some mock provider called DAG. It will publish a certain amount of DAG data pieces to the Pando instance, the Pando service. And then we can use a metadata query interface to query the state and the snapshot information. Okay, so now I can show you here. I just restarted the container before the demo. So the Pando service is just started. And first thing I need to do is to register. I can use this command to, and I will talk about the command parameters. So you can see from the logs, so register provider, and you can see this is the peer ID. This is also what I provided here. So this is the peer ID provided. The idea is that I want to tell the Pando service, I want to register this peer to the service, and I'm going to publish data change to the service. And this is a parameter to tell where the Pando is. And this is the provider address. Provider is this is a mock provider, the multi-address of the mock provider. Optionally, you can also provide a miner account. This is used to set up the rate limit. I'm going to talk about shortly. So you don't have to, but you can. So we have different policy set up for the miners. So this is to register. Next step is send some DAG update. So I'm going to switch to the binary directory. Okay, so what I do here is, okay, I'm going to send 5 DAG data pieces to the Pando service. And if I go to the logs, actually you can see here, there's no data received. That's because the Pando service hasn't subscribed to the provider. So this is what I need to do here. So I need to subscribe. We build up this API to subscribe to this peer. This is the peer ID of the provider. So we subscribe. Then let me send the data again. Okay, let's go back to the logs. Now you can see there are a lot more logs here. It means that the data has been synchronized. So I can take 1 or 2 CID and search here. So you can see here, this is a GraphSync request for that root CID. The following logs showed us the sync process here. This is the process to sync the whole DAG piece and finish here. So this is how we synchronize the data. The other thing I want to show you is the snapshot. So this is the API we use to query the snapshot list. So there are 4. If I send another 5 DAG data to Pando service, we should see a new snapshot generated. So currently, the mechanism of the snapshot is the Pando service will pull every 5 seconds and see if it see any data change or new data received, it will populate a new snapshot. So in this case, we should expect 5. Yeah. So these are the 5 snapshots. We can use this info API to query the snapshot information. And the update field gives us the data change in this snapshot. So you can see this is the peer ID of the provider. So this is the mock provider, the peer ID of the mock provider. I also use it in the registration phase. You can see it here. So when I send the data, the DAG data to the Pando service, I provide let me show you the command line arguments. The provider private key, the block number, it should be the DAG, the number of DAG data. Also the Pando peer ID, Pando multi-address. This parameter is to tell the mock provider to stay for amount of time, and the transferring will still be in progress before the command execution completes. So this is the mock provider. And let's go back to the output here, the mock provider output. There are 5 CID, root CIDs. So if we search, we should see all of them here in the list. So 5. I'm not going to search all of them. So you can see 5 CID. It's wrapped. They are wrapped in this snapshot. And in future, we will also enhance the snapshot mechanism to support more features. It doesn't have to generate every 5 seconds, but for now, for demonstration purpose, we implement in this way. So it's also the snapshot also chained together by the pref snapshot field here, you can see. So this is the most recent one. So this is the previous one. So you can see the height is like the index of the snapshot in the chain. So this previous one should have the height 3. So this is how we manage the snapshot chain. And we can also query snapshot by height. So this is the HP interface. We just see the snapshot with height 3. So this is the one how you can query by height. And then you can also see in this snapshot what's the data change for this provider. In this case, we know that this provider has 3 or 5 more DAG data populated to Pando service. So this is the snapshot. Okay, and next step is the state query and the snapshot query. I just show you how to list a snapshot and query the detailed information of each one. And this is the GraphQL interface that we can query more information. So for state, you can understand or you can learn the latest up-to-date status of all the providers. So by giving a provider ID, you can query status, the state, including the CID list, the last updated timestamp. So let me use I think it's the same peer ID, but let me confirm. So this is the peer ID. If I use it and run the query, so you can see here, state return you all the root CIDs it saves for the provider. And the snapshot give you the corresponding snapshot information by the CID. What is this CID? It's a snapshot ID. We can use, for example, this one. So this one is a snapshot with height 3. We can copy and paste here and run again. So you should expect the same snapshot information in the response. We still need to make some tweaks to the API so that it can properly display the structured data in the response. For now, it's just a plain string, which is not nice. So this is a GraphQL interface. So this is how you can query the state and the snapshot. We will have we have the interface for the consumer to pull data over GraphSync. But for now, we are still working on the mocked consumer. So we are not able to query the DAG data and unmarshal and then display in a human readable way. So this will be the next step. The last thing I want to talk about is the rate limit. So I also put this link in the slides. So this is a rate limit design and the policy in Pando. Considering the times, I'm not going to go through all the details. So in general, it's based on token bucket algorithm. And this is the data flow. So for each request, it will try to get a token. So until it gets a token, it won't fire off to the provider and pull the data. So it will wait every 1 second and try again until a token is retrieved. And this is the gate limiter, and we also have peer limiter. The peer limiter is designed based on the bandwidth of the current Pando service host, depending on the network status. And we have some factor to control for different peers. we have unregistered peer, wireless peer, and the registered. Registered peer is associated with the provider having the miner account. So in general, different account level has different weight. Different weight determines the different bandwidth it can take. So this is the rate limit. For now, I can quickly show you an example. So this is a Pando config. So you can see the bandwidth here. This is decided in the initialization phase of Pando. We have a command Pando init. I'm not going to re-init again, but in the init phase, it will detect and set up the bandwidth based on the network status. And for now, I can manually change its configuration and set the bandwidth to 1. So which will be the minimal value we can think of for this configuration. And now I need to restart the container. So based on the theory and the algorithm, we should expect that each request, it will wait for a second, 1 second to get a token. So if we set the bandwidth to 1, so every second there will be one request, there'll be one request allowed. So you should expect in the log that the block will be synchronized in 1 second. So if I send 5 DAG pieces, so it will be done 1 by 1 in every second. I think it's up and running now. Let me quickly subscribe and send the data again. Okay, so 5 DAG root CIDs. Let's go back to the logs. So you can see here, unpaused. So this is 17-second request 2 unpaused. And let's move on. So this is 18. Request 4, so this is 19, which means in every second, there's only one request fired off to the provider and the one that got synchronized. So this is how we implement the rate limit for now. We are also going to improve the algorithm to support more dynamic situation. So that'll be the next step. I also put a link here for reference in terms of the rate limit policy. The next step is that firstly, we are going to implement the mock GraphSync consumer. So in this, with the mock consumer, we are able to demo more features on the GraphSync interface. The other thing is the rate limit on dynamic DAG size. For now, we just limit the DAG size, one of the factor of the algorithm, to be 1 megabyte. So we need to support more DAG size. Third thing is the IPLD data backup. We are going to back up the data to the Filecoin network. The last thing will be the performance testing. We might not be able to finish all of them in next 2 weeks, but hopefully we can make 3 of them, the first 3 on them, in the next 2 weeks. So Xiaohua Zhang and Ben Xu are the main contributors to all these feature development and bug fixing. Really thanks to them. And I believe the QA session goes to Slack as usual. Thank you very much. 谢谢。
Sure. Thank you very much. Yeah, please post the GitHub link onto Slack as well, just so we can all have a look at that repo.
Sure.
I'll stop the recording now. There is one question on Slack, and we'll go to that after I've finished the recording. Thanks, everyone.